Good morning, Physics 1 class. Apologies for the incredibly awesome setup here, but I'm doing this from home, so you can use my incredibly awesome whiteboard. Wanted to start with going over the lab. So there was some confusion, admittedly, on kind of numbers 11 through 15. So I want to kind of break those down. So I went ahead and took them and rewrote them and turned them into 1 through 4 on Lab C that you picked up. So number 1 and number 2 are talking about where is this missing energy going. So when you did 9 and 10 on Lab B, you should have found that the percent difference between your potential energy at top and your kinetic energy at the bottom was fairly large, probably somewhere between 40 and 60%, depending on what numbers you got. And that's normal. That should have been like that. So don't worry if that's what you got. That should have been what you had. But I want to know where that missing energy is going, because it shouldn't be. We should find that the potential energy turns into kinetic, just like work done to raise the marble turned into potential energy. The potential energy that the marble has should turn into the kinetic energy. So they should be the same, and they're not. So why aren't they? There's a missing energy here. What we found is that the potential energy at the top is actually turning into two types of energy. One of them is the kinetic at the bottom that we've already talked about. And while kinetic is motion energy, we only accounted for one of the parts of the motion for the marble. So it's easy to say that friction is the reason why the energy is missing, but it's not, because we know for rolling objects friction is really small. So it has to be something else. Instead, we included the linear motion of kinetic energy, the forward motion of kinetic energy. We did not account for the rotation of kinetic energy. And so there's another type of energy that we're going to call rotational kinetic energy. Now I have good news. We're not going to solve this. We're not going to do all of this crazy math. We're not going to add it in. We're just going to take it out of the problem so that we're left with what the kinetic energy should have been. Instead of assuming the kinetic energy should be the exact same as the potential, we'll figure out how much kinetic should we end up with, and then we'll see if your numbers match that. So the easiest way to do this, the easiest way to get rid of this kinetic energy rotation, is that I calculated that it should be about 40% of your potential energy. Okay? So since that should be about 40% of your potential energy, it follows that this should be 60% of your potential energy. So the simplest way is to multiply your potential energy that you got when you calculated in, I believe, number 3 on Lab A, to multiply your potential energy by 0.6. That would give you 60% of the potential energy, and that is what the kinetic energy should be. Okay? This right here should end up being 60% of the potential energy. The other thing you could do is you could set up this equation, plug in your number for potential energy. This number will be 0.4 times your potential, and then solve for what Ke is. But I think this will be the easiest way to do it for most of you. Once you've done that, this number, whatever you get for 60% of your potential energy, whatever you get for Ke, that's your new expected value for number 3. And then your measured value would be your averages from the chart. So you go to your charts that you did in Lab A, and you use those numbers there to be your measured. I would go ahead and average them together so you only have to do one calculation. And that'll take care of getting you your percent error. So that should take care of everything on Lab C. That should also help you wrap up Lab A and Lab B. The whole thing is due here at the beginning of the period. I will have the sub give you a little bit of time to finish, but you should have been done with most of it already and just have this last part to finish with. So I'll give you a little bit of time to finish, but not a ton. Turn it in, and we'll get started on the next part when you're done.